I think I should start. Should I? Yeah? Okay. Hello, everyone. I hope you can still hear me in the back. We had some microphone problems in the last session. Yeah, this is better? Okay, perfect. Okay. Hello, my name is Alexander. I work as a software developer, and I usually use PHP and Symfony and Doctrine in my projects. And I also like open source, and this is why I contribute to a lot of open source projects. And for some projects, I did this a bit too often, like for Symfony and Doctrine. So I was asked to join the core teams. So I also help maintaining Symfony and Doctrine nowadays. I also, in my projects, like working with code that, well, has aged like a good whiskey. And when I'm not working, I take care of for long-term support releases at home. So for those of you who don't know Symfony, this is first of all an application framework, but it's also a set of reusable components. And so even if you don't have a full stack Symfony application, you can still use selected components that help you to not reinvent the wheel. And now maybe I'm at the wrong conference here because I'm talking about Symfony, and this is, as I've learned, a Typo 3 conference. So what am I doing here? As I've also learned, Typo 3 is in the progress of migrating towards Symfony components, or using Symfony components under the hood, and also using Doctrine, at least the database abstraction layer under the hood. So this is kind of where our worlds collide now. And one of the what I know about how Typo 3 uses Symfony, for instance, is they use the dependency injection components nowadays. It used to have its own self-invented lifecycle management, object lifecycle management system, and there was something called, what is it? General utility make instance to create objects. Interesting, okay. And it used to have I need to read this up because I've never heard of that. A somewhat dirty system of overriding services or entities called X-class. And for some reason, people want to get rid of that. And they won't for a very long time, as I also heard. But the transition to Symfony DI is kind of the idea behind this. And a Typo 3 extension can expose a services.yaml file, which allows you to configure services inside the Symfony dependency injection container. So this is what I know. I hope that this is somewhat correct. As you might be guessing, I haven't worked with Typo 3 that much. So I know quite a few things about Symfony DI, so I will be talking about that component. So my talk might feel a little bit disconnected to Typo 3. I hope this is still okay, and I hope that most of the stuff that I'm presenting today is usable in the context of a Typo 3 application. Also, if there's some water for the speaker, I don't have any. If you have a bottle of water, that would be great. So, first of all, what is dependency injection? Maybe you have never used this before. Here's a small example for what dependency injection is not. So let's imagine, I can draw on this, right? So let's imagine we have a little class called a newsletter dispatcher, and this newsletter dispatcher needs a mailer and it needs a logger. So it creates its mailer, it creates a logger, it knows where the mails can be sent, it knows where logs can be written to. Oh, awesome, thank you. And so it sends a mail, and then it logs that it has sent a mail. So great. But what's the problem with that? Well, the problem is I need to know the exact configuration of my mailer. That's kind of a bummer because yeah, maybe this changes in the production environment. Maybe in my development environment, I don't want to actually send emails through a production mail server. I need to know where the log file is placed. This is also a bummer because maybe at some point I don't want to log into files anymore. I want to log somewhere else. And maybe I want to put even if I log to files, maybe I want to put those logs somewhere else. So I have to change a lot of code to adjust this. And also for testing, we just had a session about testing with mock objects. Maybe I want to have a mocked mailer or a mocked logger for my testing. And yeah, this is also not possible in this scenario. So what we see here are hardwired dependencies. So those are not changeable. They are not configurable. They will always be tested with your code. So if you test this newsletter dispatcher, it will actually send mails through your production mail server. And also, this is not explicit. If you look at the headers of your PHP file, of the class file, you do not see which dependencies are being used somewhere down there in line 7641. So those are problems that should be solved with dependency injection. So first of all, what is dependency injection? Maybe you have never used this before. Here's a small example for what dependency injection is not. So let's imagine, I can draw on this, right? So let's imagine we have a little class called a newsletter dispatcher, and this newsletter dispatcher needs a mailer and it needs a logger. So it creates its mailer, it creates a logger, it knows where the mails can be sent, it knows where logs can be written to. Oh, awesome, thank you. And so it sends a mail, and then it logs that it has sent a mail. So great. But what's the problem with that? Well, the problem is I need to know the exact configuration of my mailer. That's kind of a bummer because, yeah, maybe this changes in the production environment. Maybe in my development environment, I don't want to actually send emails through a production mail server. I need to know where the log file is placed. This is also a bummer because maybe at some point I don't want to log into files anymore. I want to log somewhere else. And maybe I want to put even if I log to files, maybe I want to put those logs somewhere else. So I have to change a lot of code to adjust this. And also for testing, we just had a session about testing with mock objects. Maybe I want to have a mocked mailer or a mocked logger for my testing. And yeah, this is also not possible in this scenario. So what we see here are hardwired dependencies. So those are not changeable. They are not configurable. They will always be tested with your code. So if you test this newsletter dispatcher, it will actually send mails through your production mail server. And also, this is not explicit. If you look at the headers of your PHP file, of the class file, you do not see which dependencies are being used somewhere down there in line 7641. So those are problems that should be solved with dependency injection. Dependency injection basically means that my dependencies are being injected. So I have a constructor, in this case, from my newsletter dispatcher, and my newsletter dispatcher receives a mailer, receives a logger, and then when I actually send my newsletter, those two objects are being called. For those of you who don't know this notation yet, this is constructor property promotion. This basically means that the value that is passed to this constructor parameter is directly stored in a property. And for dependency injection, this feature of PHP 8 is really awesome. So if you work with dependency injection a lot, then you probably will find yourself using this notation quite often. And even if you don't like it at first, you will learn to like it. So what is dependency injection? Dependency injection is first and foremost a design pattern, and it allows us to compose big decoupled architectures. And it also enables us to develop against contracts instead of real implementations, which allows us to replace implementations, as we learned in the previous session. But this generates another problem. In this case, my newsletter dispatcher receives a logger and receives a mailer, and those loggers and mailers also have constructors, and if in those constructors we also see dependencies being created, then this ripples down, right? So my logger probably needs some storage backend, in this case, a class that I call a file writer. The mailer probably needs some kind of transport, in this case an SMTP transport, or maybe in the future it needs a transport that sends mails not through SMTP but through some fancy web API of the mailing service that you're using. And maybe the mailer also wants to perform logging, so it might also need my logger, and it might be great if it uses the same logger. And in that case, whenever I need to use a newsletter dispatcher, I would need to construct all those objects, although I just want to send a newsletter. So this is the code that we see here. This is all the code that I need to actually create this newsletter dispatcher. And this is probably not what I want to do if I only want to send a newsletter. So the problem of constructing the dependencies is not gone. It's just moved somewhere else. It's moved to the place where I need the topmost dependency. So the solution to that is that I use another design pattern called service location, and this is basically the pattern enables me to, or gives me an object that I can ask for all the services that I use in my application. So it's kind of like a registry of every service that my application knows about. And this container, it's a container because it contains all the services, right? So this container knows how to construct each service. So ideally, the container does not contain all the services already constructed, but it knows, or it has blueprints, like factory methods for all the services. So when I ask the container for a newsletter dispatcher, it knows how to create it and how to create its dependencies. So the dispatcher is then being created recursively because the dispatcher has a dependency on the mailer, and then the container looks up in itself, how do I construct a mailer, and so on. And when I ask the container a second time for this newsletter dispatcher, then ideally it will give me the already constructed one. So it remembers what it has constructed already and gives me this object. This is a single mechanism in this case. This makes my life a bit easier, because now I can say, dear container, give me my newsletter dispatcher. So the trap in that you are lured into with those two patterns is to actually combine them, because they both looked very juicy, right? So I have a container that knows about all the services. So instead of going through the pain and declaring all my dependencies in my constructor, I could simply inject the whole container and then asking again for the services that I want to have, right? So this is not dependency injection. Don't do this. It will make all the benefits that you gain from dependency injection are basically taken away again, because in this case, if you want to mock a dependency because you want to test something, then you have to inject a container with mocked dependencies, and this is not getting better then. So please do yourself a favor. Don't inject the whole container into anything. Okay, so one container that you could use, for instance, is the Symfony dependency injection container, or the Symfony dependency injection component. This is the one that Typo 3 decided to use, as far as I know. It implements the PSR 11 standard. This is a common standard for dependency injection containers that was established by a group of people who think about interfaces that could be shared between or among different frameworks. So even if you when you're afraid to develop against a container that is like proprietary, then with this interface, you make even the container somewhat interchangeable. So this is what our example would look like in a services YAML configuration file. Very explicit, all the services that we have are defined here. And yeah, this is probably the most verbose way of configuring this, and this will probably also be the most verbose way that we look at this configuration file today, because I will be taking away a couple of things there that are too obvious or too that are too repetitive. But yeah, we see here. Can point on this here. We have our logger with the dependency of the file writer. We have the file writer service. For each service, we define a class and we define the constructor arguments. In this case, the file writer has a path argument, and I pass in the hard-coded path. Not so nice, but we will change this later. And in this case, our logger needs a writer, and here I reference another service. I do this with this little @ symbol, and then I reference a service ID. So this service is being injected here. So pretty straightforward. I just tell the container what to do if a certain service is being requested. And we have the same here for the mailer. The mailer needs a transport, so we have the SMTP transport service defined here, and it needs a logger, so we use the same logger as we defined here. And we have finally our newsletter dispatcher. It is a instance of newsletter dispatcher. It receives the mailer and the logger, and it has to be public. And I will show this later why it is public. One thing that we have to keep in mind here is that our container is being compiled. So this YAML file is not sourced whenever you receive a request. This YAML file is sourced once when the container is being compiled. Then we compile a bit of PHP code out of this YAML file, which contains all the factory methods that our container needs to know about. And afterwards, the container is always read from this compiled file. So you don't have to be afraid that we pass YAML on each request. This is being abstracted away from us, or this is only being done once. Also, what this compilation allows us to do is we can add certain magic to it, and we can optimize a couple of things. And we can also change the dependency tree during compilation. So what we also need to think about is that all those services are or should be immutable. They are singleton objects, so if I request the same service twice, I will receive the very same constructed object. This can be changed through configuration, but I would advise not to do so. Please avoid storing any state actually in those services. Okay, thank you. I might have hit the spot here. Also, any data objects like domain models, DTOs, ORM entities, they don't belong into the container. Also, stuff like the current request or the current user, those are not services. This is data. You might have a service that can fetch the current user for you, or that can fetch the current request for you. This is fine, but you should not use the current request or the current user as a service. Everything that is, or every service that you define is should be available during compile time. So we cannot change the services or the configuration of services for each request. This is also something you have to keep in mind. This is a container that is compiled once and then it's fixed. So the one thing that we can optimize to compilation is we can remove services that are not being used, and we can inline services that are only being used once. And how do we know if a service is used or only used once? Because we can configure a service as private and as public. If we define a service as public, then you can actually fetch the service through container arrow get. Then this service will be available there. If it's private, then container get will not know about the service. It's completely unknown to this method. But it can be used as a dependency for other services. So and if we know that a service is only available as a dependency for other services, and we see that the service is not being wired into any other services, then it can be removed from the container because it is not being used at all. This makes the container a bit smaller. And if we see that a service is only wired once, so only one service uses this service as a dependency, then it does not have to be a standalone service. It can be, or the factory method for this service can be inlined into the other service. This also makes the container a bit faster. Services are private by default, so services are only public if we declare them public, like we did with the newsletter dispatcher. This is a service that I probably want to fetch directly from the container at some point, and so this is why I declared this public. And all the other services that I declared, they are only dependencies of that one service, so they can be private. So this was our configuration file again. As I said, this is the most verbose version of the configuration file that we will see today. So how can we make this a bit smaller? So well, yeah, this makes it a bit larger actually. So the one thing that we want to extract first is parameters. Parameters can store scalar values or arrays, and I could, for instance, load those parameters also from external sources. We're not doing this today, but just keep in mind that you could do that. And we could also load different parameters for different environments. So let's say I want a different mail server on my staging system than I want to have on production. This is where parameters come in handy. Also, maybe I just want to have all the values that I want to keep changeable in one place, so I can extract them to those parameters. And as we can see here, the path that we had here is now referencing a parameter. We see the parameter with those percent signs before and after the parameter name, and the parameters are defined under those parameters here. Same as for the SMT transport. This is also now referencing a parameter. The parameters can be defined in the same services YAML configuration file, or we can tell the services YAML configuration file to load another configuration file, and maybe this is a file that we put in Gitting or something. So this would be the easiest way to make parameters changeable. Because my next examples all should fit the slide, I will not repeat this parameters block anymore, but just keep in mind that they have to be somewhere. So the next thing that we could simplify is our service IDs. I chose service IDs here that look like something that is really an ID, because I wanted to make you aware that the service ID and the class name are two different things. But since we all know that naming things is hard, and I already had much trouble finding a proper name for my class, why should I go through this trouble again and find a proper service ID name? This is, I don't want to have this trouble anymore. So I just pick the fully qualified class name as the service ID. This makes things a bit simpler. And also the container supports me in doing this because I can, because when I use the fully qualified class name as the service ID, I don't have to repeat this class property anymore. I can just omit the class property because it can be derived from the service ID. This makes the file a bit shorter. And this is where I have to take a sip of water, sorry. So, but still this feels as it should be easier than all this verbosity that we had here, especially if we use fully qualified class names as service IDs. So if we look at the constructor of our newsletter dispatcher class, we have proper type hints here. So we have native PHP types that tell us only a mailer, only a logger can fit in here. And we have two services that have exactly the same type as their service ID. And it feels like there should be something that is smart enough to put this together, right? So this is what we call auto-wiring. So what we can do is we can switch on auto-wiring for a service, and then we can under-specify the constructor parameters. What happens then is that during compilation, the container will look at the constructor, will check if all the parameters are fulfilled, and if they are not, it will try to find a service where the ID matches the parameter type. And if it finds that service, then this service is automatically wired. So this makes our argument lists a bit shorter. Okay, but we had a problem with the interfaces. We could directly wire those two services because they reference a class. But in case of our in our transport or the writer, the classes that depend on those actually depend on an interface. So the logger doesn't tell you it wants a file writer. It just says, give me something that implements the writer interface. Because the logger has no opinion on if it's logging to a file or if it's logging to some kind of network server where the logs are being sent to. It just wants to have something that transports those logs. And what we can do is we can define a service alias, which basically means that a service is also available under a second ID. And if we pick the interface name as the alias, then auto-wiring also works for interfaces. But we want to auto-wire even more. And for the parameters, we couldn't do this yet. And now I'm introducing an attribute here. So for the SMTP transport, it wants a DSN where the mail server resides, and I put in a small hint here that says if you try to auto-wire this, then please use the parameter mailer DSN. So this is where our parameters really make sense. So now I can use them here directly. And this also means that I can now auto-wire my SMTP transport. And of course, I can do the same for my file writer, for the location of the log files. And then I have a configuration where all my services just have auto-wire true in them, and since I don't want to repeat the same configuration for each of those services, I have a way of defining defaults for my services. So if I have this special service named _defaults at the top of the file, I can define properties that apply to all the services that are defined in this configuration file. So if you're splitting your services into multiple services YAML files, then you have to repeat this defaults for each of the files because it only applies to this very file. So now we have, like most services, service definitions are now empty because we auto-wire them and we say we want to auto-wire everything. So this also makes the file a bit smaller. The only thing that's left here is the newsletter dispatcher. I still have to say it should be public true. So how do we get rid of this? Oh no, this is not okay. We look at this first. Okay. Yeah. Okay. I changed the order of the slides tomorrow this morning. So it's too warm in here. So what actually happens here is that, or what I want to have is, if I only have like empty service definitions, then I don't want to enumerate all my classes that are in my applications. It's kind of pointless. So what you can do is you can define a namespace and point that namespace to a relative path on your file system relative to your services YAML. And this basically tells the container to scan this directory recursively for all PHP files and assume that those files there are stored under the PSR4 naming standard, so that class names and namespaces are mapped to folders and files on the file system. And then all the service, all the classes that are found there are being added to the container as services. This might feel overwhelming at first, because do I really want to add all classes that I have to the container? Because then I would load the container with a lot of services that I might not even use. But this is not a big problem, because as we've learned earlier, all the services are private by default, and private services that are not being used are being purged from the container again. And since all this happens during compilation, this basically has no runtime impact. So this makes our life easier, because I don't have to, like, when I add a new class that I want to register as a service, I don't have to like add it on the file system and then add it in the services YAML additionally. I can just tell the container to use everything that is in that source folder. But I still have the ability to override the service definitions that come from this auto-discovery. In this case, the newsletter dispatcher still needs a different configuration, so it will be found during the auto-discovery, and it will be added during the auto-discovery, but down here, I say, well, forget everything that you learned about this service. Now I tell you the real configuration of it. So I basically override what I've discovered already. And there's still those two interfaces that I'm aliasing here. We also heard in the previous session that it might be a good practice to have to finalize your services and have interfaces for those final classes. And this is also something that is being supported here. So if during this auto-discovery the container finds a class and an interface, and this class is the only implementation of that interface, then this alias that we see here is being created automatically. The reason why I left those interfaces aliases here is I assume that I might have more implementations of this log writer interface and of this transport interface. So this is why I still keep the aliases here. So if you have like two implementations of them, then you have to do make this alias yourself, because the container wouldn't know which of those two implementations to wire. So now we're getting rid of the public in the configuration file. And we apply another configuration option here, which is auto-discovery and auto-configuration. So much auto today. Auto-configuration. This basically means that whenever the container encounters a class of a certain type, then it will apply all those configurations that I configure there. So for instance, in this case, the newsletter dispatcher, I define it as public true. This is my explanation was a bit too complicated for this because it's just a single class, and whenever it encounters this final class, it's only this class, right? But you can also attach this auto-configure attribute to interfaces, and then this piece of configuration is applied to all implementations of that interface, and this is where it gets interesting, and we will see this later. But for now, we do this only for this service that I want to declare public, and this should simplify our file again, because now our newsletter dispatcher doesn't have public true, it has auto-configure true. And since there's no downside in auto-configuring simply everything, I can pull up the auto-configure true to the defaults block, and then my service definition is also gone. And yeah, everything goes through the auto-discovery. And this is actually how I want to build applications nowadays. I don't want to write a big configuration file that defines all my dependency injection. I just want this small file that says enable all magic, and then the discovery to pick up all my services. Why did I show you the configuration file anyway? Because I want you to be aware of what the services actually are that are being configured. Because the service container that is now being compiled is actually the very same. There's no difference. It's the same container. It's just that the configuration is more implicit. Okay, so yeah, this is the file that we have now. Yeah, now this makes everything short. I want to do a small or implement another task. So we have seen our example with the newsletter dispatcher, and now we try to build something different. We want to import data from a CSV file, and this CSV file probably has a lot of different columns with varying quality, I would say. I will make this file brief here, but you could imagine that such a file, such a data importer could get really large. We assume that we already have a component that actually reads this file line by line and gives us an associative array where the column names are only mapped to values. So if we read the first line, we already get this array here. But what we want is we want to properly typecast this array and properly hydrate this, and also check if the values are correct. So we want to validate the input data. Okay. So how would we do this? We probably have some kind of method there that says transform value, and then we have a very big switch case block in there that sees that if it's an ID that we are parsing, then we probably want to see that it's an integer, and then we cast it to an integer. And if it's the alive column, then we want to see if there's yes or no in there, and then cast it to Boolean, and so on. And we could imagine that this is not very extensible. So if a new column is being added to our format, then we have to edit this big switch block. And also, this file is probably getting pretty large. And if you want to test this, if you want to test the validation of every single column, then you have to prepare a fake CSV file for each of the edge cases that you're testing. This is also probably not what we want. So we invent a small interface that is only for a service that is only capable of transforming a single column. It can tell you which column this is, and it can perform the actual transformation. And this makes stuff easier. As we can see here, this is the implementation for this. This makes stuff easier because now we have the collection of all those transformers, and if we want to transform a value, then we loop over all the transformers, and if we find the right transformer, then we simply perform the transformation. Otherwise, we throw the exception that we saw earlier. So this is all all very great, good. So how do we do this with dependency injection? So first of all, our auto discovery wouldn't know what to inject into this parameter column value transformers, but it did actually find all those implementations already. So I can simply overwrite the file importer service and say, well, in the column value transformers, just inject a collection of those services. This works, but as I said earlier, I don't like writing verbose configuration files. I want to make this easier. So here we can use a mechanic this is called tagged services. So I can attach as many tags as I want to my services, and this helps me to find a certain group of services during compilation. After compilations, those tags have no meaning at all. It's just that during compilation, I can find services that might be scattered all over my application that are tagged a certain way. And this helps me because I can now use an auto-configure attribute for my interface. I can say whenever you encounter an implementation of this interface, please attach this tag to it, to this service. And then I can also annotate my constructor parameter and say, well, in this parameter, I want to have an iterator of all services that have a specific tag. And this allows me to remove this service definition again from my services YAML, because now the container knows I want a collection of all those services injected there. Yeah, maybe this is also not what I want. Maybe I don't want to loop over those services. Maybe those services already know what they are responsible for, or what they or which column they can transform. So what I want instead is I want to have something that can ask for the right transformer for the column that I'm actually transforming right now, and then I directly transform the value with that transformer that I've looked up. And what I use for that is I use an attribute called autowire locator, and I tell it how this locator should be indexed, and I put the get column name method there that all my transformers already implement. So what I receive is a small container that contains only the services with this specific tag on it, and where the service IDs are actually the column names on my CSV file. So in this case, I can simply ask this container for the transformer that I need. If this is not found, I can throw my exception again. I pretty much know that only implementations of that interface are in there, and I can run the transformation on this. Yeah. So yeah, this is called service locators. So it's actually a projection of my one big, large application container, and it contains only a handful of services that I need. And like in the big container, those services are only being constructed when I actually access them. Yeah, I saw that my time is running out. Well, this is, I think, the last example that I have. So I mentioned that I have the problem that I want to intercept calls to an HTTP client. I want to log everything that goes through this HTTP client. So I have a service here, a traceable HTTP client. I inject the real HTTP client in there. I have my own self-invented logger again, and I want to log a request there. So how do I configure this in my service configuration? This sounds pretty complicated if we think about it, and this is probably why this decorator pattern, because it's something that people use quite often, is directly built into the container. I can say that I want to decorate the client interface service. This is, again, a service ID, not a class, it's a service ID. So I want to decorate this, this service client interface. And the actual service is being injected here. So whenever somebody wires or auto-wires this HTTP client, it will actually receive my decorator, and I can intercept all the calls that are being made to this service. So to sum this up, Typo 3 nowadays leverages the Symfony DI component. I like the component, and I would advise you to actually use it. It allows us to build decoupled architectures, and it also enables us to change dependencies during tests or maybe in developer mode. And configuring all this is really a breeze if you use auto wiring. So I thank you for your attention, and I think I'm open for questions at least, at least one. Yeah. Okay. Okay. Ah.
If a service should have no state,
Yes.
can you explain us the difference between a service class and a static class, which
What
also doesn't have a state?
what was the second one?
Static. A static
Static
class.
class.
Because I think there used to be used static methods and static classes for what we use services now, but
yeah, got that. So no state was actually what I meant with no state was the only state that the service should have is its dependencies, and a static class cannot have dependencies or not configured ones. It only can call other static stuff. So it depends on the global state, which is kind of what you don't want, because global state is hardly replaceable for testing purposes. So the whole point of a container or a service container is that I don't depend on the global state. The only state that I depend on is the state of my container.
So thank you for your talk. It's just a small question because of I also told in my talk that we are going to use the PHP attributes for this kind of stuff to reduce the services YAML files. So that was basically my question. So you also encounter people to use the PHP attributes when possible instead of defining in services YAML.
It makes stuff easier. Yeah.
Okay, thank you.
I know that there are people out there that like writing big configuration files, and there's a big intersection with people who like XML. I don't like coding in XML or YAML, so I like that if configuration is like co-located with the code that I'm configuring, and this is what attributes allow me to do.
Yes. Thank you.
Okay, then, thank you very much.